part 3 of stress?
Sir, no, no, no part.
So you completed the stress, right?
Yes, sir.
Okay, so Priyansh already told me. So Sudhir, what about you? You completed up to stress. Did you all get the announcement?
Yes, sir.
Okay, so you
Completed.
completed up to stress, right?
Yes, yes.
So you have any query?
Not, sir. No, sir.
Yes.
Sir, I want to ask one thing.
Yeah, go on.
Sir, in stress lecture part 1, in the
Mhm.
last page, I mean, in the PPT, in last page, um, there was uh, sign
Stre-
convention.
Stress lecture 1, right?
Lecture 1, last page,
Okay, so stress
last
part
slide.
1, last page. Yeah, I'm there. Yeah, anti-clockwise
Yes, sir, yes, sir. Uh,
positive and
once I asked,
clockwise is negative. Yes. Yeah, I see what you are asking. So, so you are asking, right, why the dextral is positive, right? Dextral is negative
yes,
written
sir,
here,
yes,
right?
sir, yes, sir.
Yeah, so that's not right actually. So dextral is always positive, right? Right?
Okay, sir. Can I mean, is there any source where I can find a reference for this?
Yeah, in the books you can find like there are the books that is written in the course, right? In the first lecture, I guess there are
Yes, sir.
references of the books. If you read those books, there will be this kind of things, right? So positive is always clockwise and negative is always anti-clockwise, right? That's why they have this sinistral and dextral term, right? Yeah, so I think most of them who are about to join are already here. So I'm going to start for today. So yeah, the people who are here, I just want to ask for one more time, right? That you all received the announcement, right? That we have to really go through up to stress because after this part we will be covering the rheology, which is entirely different part. So if you do not have the knowledge of stress, it will be difficult to continue with rheology and later on. So things are like that, right? So you all have completed up to stress, Ashwini and Prabhakar. Prabhakar, Ashwini. So people who are here, I am just want to ask like, have you completed up to stress? Okay, so there is no reply. Okay, all right. See, in structural geology, there are uh, basically two parts that we deal with, or maybe three, right? So the first part is about the observations that we do on the mesoscale level. That is, on a field, you are seeing a fold, fault, or something like that. Like in a field scale, if you are observing any structures and you are interpreting from those structures, those fall in one part. In the other part, uh, that is from the micro scale, observations from the micro scale, where you prepare the thin sections. So from the thin sections you want to analyze the grain orientations and like what is the deformation of the lattice and all that. And there is another part that is related to the tectonic scale, or I am writing it here like macro scale. So if we want to like whatever we have learned till now, we know, right, stress and strain all can be measured in these three scales. Are we clear? Hello?
Yes, sir.
Yeah. So so now for the rheology part, what is rheology? Rheology is basically deals with how a material responds to stress or force. All right. So this is the first time you are hearing the term rheology, or you heard it before?
I have heard already, but I have no. I mean, I don't have much idea about this.
Okay. Others,
Sir, I
please.
have heard.
सो आप लोगों को रियोलॉजी के बारे में पहले, मतलब पहले आप सुने हैं ये टर्म, या आप पहली बार सुन रहे हैं? आर यू हियरिंग इट फॉर द फर्स्ट टाइम, और यू लो लिटिल बिट अबाउट इट?
सर सुना हुआ है रियोलॉजी का।
फर्स्ट टाइम सुन रहे हैं सर।
ओके, फर्स्ट टाइम सुन रहे हैं. एंड अदर्स?
सुना है पहले से.
ओके. ओके. So what do you know about rheology? Like, what is your idea? Can you, those who have heard the terms, can you tell? Like, can you share? What do you know about rheology? Suppose I'm going, if I say like a rock is showing um, viscous rheology or elastic rheology. So what do you understand from that?
सर
Sir,
रॉक
we
के
just
शेप में
know.
जो भी
Okay,
डिफॉर्मेशन है।
one by one. Okay, you just raise your hands and then maybe I can tell, right? So yeah, go on. Someone please go on first.
सर रॉक के स्ट्रक्चर में जो भी डिफॉर्मेशन आ रहा होता है उससे रिलेटेड है रियोलॉजी। डिस्कस रियोलॉजी इन द सेंस कि जब उसमें टेम्परेचर और प्रेशर की वजह से उसका जो मेल्टिंग एवरेज जो कुछ भी होगा उसके थ्रू जो इनिशियल से जो चेंज होगा उसको मेजर करेंगे।
Okay, that's not quite right, because जो भी changes होगा, you are studying it under strain, right? जो भी changes होगा, right? जो भी changes दिखेगा, whatever changes that we are seeing on the rocks, any kind of deformation that falls under the strain measurements, right?
ओके सर।
So why is rheology different? How is rheology different from that? Anyone else?
Sir, rheology is a bunch of science uh, which deals about mm, the behavior of material when they are applied some kind of forces.
Okay, so what kind of behavior?
Uh, like deformation behavior, maybe.
Okay, so deformation is again falls under strain, right?
Yes, sir.
Okay, so yeah, we are not quite there, but I guess we will be there. So anyone else? What is rheology?
यस सर। रियोलॉजी वो होता है जैसे हम बता सकते हैं कि रॉक का बिहेवियर कैसा है, जब उसके ऊपर कोई फोर्स पड़ेगा तो उसका बिहेवियर कैसा होगा, जैसे कि प्लास्टिक नेचर का या फिर उस टू होगा, ऐसा कुछ।
Your voice is so what I can make out from what you just said is that so rheology is the portion of mechanics maybe which deals with how a rock or how a material will behave under the application of force, right?
Yes, sir. Yes, sir.
Okay, so but they see Kodishankor. So anyone else, somebody wants to add to that what we all have just learned? Somebody wants to add? So my question is, so there are some people who joined later. I want to, I will ask the question again, like what is rheology? If you heard this term before, what do you understand about rheology? If you, so you can say anything, right? So that is not a problem. You can just, you have to just come forward and tell the class, right? Okay. But there is a catch, right? So if you study the behavior of a material under stress or under a force, so what is we actually seeing here, right? So if we are studying the deformation, how a rock is changing its shape or volume, then we that part falls under the study of strain analysis, right? So in rheology we have another factor that is called time, right? So with time, how the material is behaving, you almost all of you are more or less right about that part, that how a material is behaving, but not at a particular instant of time, but for a period of time, right? So what will happen if a material is under stress for a period of time? What will happen? It may, how the material is behaving, right? So what will be the strain and stress relationship? So with time, maybe with the stress relationship with time, maybe the strain relationship with time, or maybe the relationship with stress and strain. So if we want to unify all those things into some kind of any parameter that you want to discuss with time, what happens is that you get to find out its rate, right? So if you want to study the speed or the displacement of a material, of a body with time, what we calculate speed or velocity, right? So like that, here also we will be dealing with strain rate. A lot of time in rheology lectures you will hear the term strain rate, right? So strain rate is denoted as epsilon with a dot on the top of it. So why strain rate is important? As I said, that we are dealing with one extra factor other than stress and strain, that is time, right? So with time, material behave differently. So some material, say for example a glass, if you for a particular pressure and temperature, if you hit the glass with some sharp object, what will happen? The glass will break, all right? But if you hit a metal, right, what will happen? It will create a dent, right? And what if you have a dough, like of a dough of maida, like how we use the thing that we used before making the roti or bread, right? What will happen? So it will make this kind of depression on the surface, right? So these three materials are behaving differently, right? So first things first, I want to clear the confusion about two terms here. One is brittle and the other one is ductile, right? So these two terms you have heard very often, right? So what is the meaning of a brittle deformation and a ductile deformation? So these are not related to rheology. These terms are related to cohesion, right? if there is no cohesion, then we call deformation as brittle deformation. So if when a glass breaks, it loses its cohesion, so we call this deformation brittle deformation. But if you stretch a rubber band, if you like squeeze your tube of the toothpaste, or like something that is very stretchy, right? So the if that is not losing cohesion, we call that deformation as ductile deformation. All right. So brittle. So we sometimes people confuse about this brittle and ductile term, these terms with rheology, but they have nothing to do with rheology. All right. So, but there are terms like plastic, elastic, and viscous. So these are the three end members. So you are familiar with the term end members, right? So if you want to, draw a triangle and you put somewhere here elastic and plastic and viscous. So these are the three end members how in which a rock can be deformed in geological time scale. All right. So what about these lines then? What about these lines? So if a rock is not deforming in a way, or if a material is not deforming in a exactly plastic manner, it is not deforming in elastic manner, but has a component of both of them. So what will we call it? We will call it elastoplastic, right? We will call this one as viscoelastic. We'll call this viscoplastic. So these are different behaviors that a material can show under certain temperature, under certain pressure, provided you are allowing a certain amount of time for that deformation. All right. So now, what about the mantle? So how do you think a mantle uh, uh, reacts with the stress and stress after, like, in geological time scale? Any idea? Hello. So are you getting what I have just said? Is anybody there?
Yes, sir. बोलिए. Hello.
Yeah. So how do you think a mantle behaves, right? Is it behaves in an elastic? Is it shows elastic rheology or viscous rheology or plastic rheology? How do you think?
Sir, please repeat the question. Your voice was lagging.
Okay, so I was asking how do you think the mantle crust, or maybe the upper mantle, lower mantle, so different parts of the earth, how do they behave? So yeah, Priyan said viscous rheology. Why is that, Priyan? So why a mantle will behave in a viscous rheology?
Viscous means because most of the materials are in molten state. That's why.
Okay.
In upper
Okay.
in upper mantle, maybe the
Yeah.
deformation will be brittle or something. Sorry, more ductiles, and with depth it turns toward more plastic.
Okay. Yeah. So the material, so the okay, so the material property that suppose so this is stress, and if we have, say for example, Young's modulus, and here is strain, so this is one form of a, say for example, Hooke's law, right? So in if a material is behaving in this manner, so what will be the plot of stress and strain? So if, so some kind of, so it is more or like y equal to mx, right? So the plot will be somewhat like this, right? If it is in the elastic regime. So this, if the material is showing this kind of behavior, so here it is sigma, here it is strain. So if a material is showing this kind of behavior, we will call the behavior as elastic behavior. All right. Suppose you have again a constant k, and that is some, that is proportional with the strain rate, then if you plot strain rate in the x-axis, then again it will be something like that, right? But if you have a material where it shows some power of, for example, like that, right? So what will be the curve here? How will be the curve here? Any idea?
Yes, sir.
So what will be
Uh,
the curve here?
and it will be convex from upper side
Yeah,
from downward.
it will be something like that, right?
Yes, sir. वही इस तरह से ऊपर से convex.
Yeah. Mhm. So yeah, n has to be greater than 1, right? So both of these cases, they are showing viscous rheology, right? But in this case, it is showing linear viscous rheology, and here it is showing non-linear viscous rheology, right? So yeah, as Priyan said, like in the Mantle, uh, the material mostly behave in viscous or elastoviscous or viscoplastic kind of thing, not viscoplastic, about viscoelastic, maybe viscoplastic kind of thing, because when you in the upper mantle, maybe where we can have the earthquake tremors from up to those depths, we can have the earthquake tremors there, the deformation rheology might be viscoelastic. All right. So what happens if you have a failure? Suppose there is a stress buildup, something like that, and there is a stress drop, and there is again stress buildup, and there is again stress drop. So this kind of curves, they actually denote like the release of strain energy, the release of, this is how the curve of the earthquake will show, right? So when the earthquake is happening, so how it is happening, it sticks and then slips, right? So all of these are actually explained in detail in the lectures. So if you go through the lectures first, then it will be easier for me to explain all these things, right? So otherwise, like in this week we have 5 lectures, so within 1 hour it is very difficult to complete the whole thing. So what I have planned is, like, I will try to help you so that you will have to spend less amount of time, or maybe if you can complete those lectures very efficiently, right? But I would suggest all of you to finish the lectures before coming to this class. Otherwise it is not very efficient how we are going to conduct these classes, right? So is there anything that you want to ask, like how to read, how to know the rheology, right? How to like those who have uh, some idea about rheology, so what to understand, like what part you find it difficult, like those things. Hello? Yeah.
हेलो सर, आपका जो होता है वो लेक्चर सुनने के लिए वो कहाँ पे है?
uh, your voice is not clear. Can you write it in the chat? Gauri Shankar Shahu. Can you write it in the chat? सर वो लेक्चर्स कौन से हैं? ये लेक्चर्स रियोलॉजी वाला लेक्चर्स है, वीक 5 का लेक्चर है. So week 6 has already released. So I actually cover the lectures of the previous week. So in the week 5, you have all these lectures, Rheology of Rocks. All right. So you are aware of this how NPTEL releases these lectures, right? Okay. Yeah. So what should we do today? I'm not sure. Like I can go like teaching all those things, but I want you to go first yourselves with the lectures, right? So are you going to complete it in the before coming to the next class, maybe? Yes, sir. Okay, yeah. So, there are some people also, like Subhash Rathod, Sudhanshu Ranjan.
Hi.
Yeah, all right. So please complete the lectures before coming to the live sessions, all right? Because
Yes,
otherwise,
sir. Yes. Yes.
yeah. So please complete the week 5 lectures. Of course, you complete the week 5. We can go with the week 5 lectures in the next class.
Okay, sir.
Otherwise, okay. So Sudhanshu and Ashima, you joined later, right?
Yes, sir.
Okay, so what we were discussing about what is rheology and what are different kinds of rheology that we face about the materials, how the materials behave in those things, right? So have you gone through the lectures?
No, sir.
Okay, so it's my request to all of you before coming to the class, like the complete the lectures complete the lectures before coming to the class. All right. Some kind of noise. Okay. Yeah. So the next class, maybe we can have one more class in the midweek also, right? Not necessarily before Monday. If we all agree, we can have another class, but you have to complete the lectures first. Otherwise, there is no point of running these sessions, right?
Yes, sir.
So you do not have any doubt regarding the assignments? Do you have any doubt regarding the assignments? Have you completed the assignments?
Sir, I have one doubt.
Yeah, go on.
Uh, so there was a stereographic projection problem in which so wait, I have to look which question it is.
Okay. Anyone else? Okay. So what are your progresses? Like up to which week you have completed? Can we have the class in this week again? This live session in this week again? Can we have that? What is your progress?
So I have completed week 2.
Okay.
Sir, I will try to complete this lecture from by today itself,
Okay.
because I'm free this week.
Don't
So
don't rush things. You can take 2 or 3 days. We can uh, have that on Saturday maybe, if
yes,
we
sir.
all agree, right? So in the discussion forum we can communicate, right?
Yes, sir.
Okay. So anyone else? Sudhanshu?
Yes, sir.
So how much of the lectures you have completed? How many of the lectures? Week wise?
So I haven't completed all.
Okay. So can you complete all the lectures before the next week?
Sure, sir. Yes.
Okay. Yeah. Subhash and Gauri Shankar, you please do the same, right? You can also do the same, right?
Yes, sir. Yes, sir.
Okay.
Yes, sir. Assignment to question number 10.
Assignment?
To question number 10.
Assignment 2. Assignment 2. You can you see the screen? You can see the screen, right?
No, sir.
No, sir. No.
This one.
Yes, sir.
In the following stereographic plot, a plane with orientation 0, 20 degrees is marked with a green color. Is marked on the plane is. So what will be the pitch? Yeah. So what is your doubt? So see, the pitch is, so this green line is the plane. All right. So and on the green line, can you see the stereo net? Is it clear or should I zoom it?
Yes, sir.
So on this stereo net, like these small circles are basically marking the angles that any lineation that, suppose if an angle is making 90 degree, right? So this is the plane. So this is the plane. So the angle is making 90 degree, it will plot somewhere here, because if you calculate from up to here to this, if you calculate these small circles, you will get 45 divisions. One division is equal to 2 degree. All right. So if an alineation is making an angle of say 10 degree, it will fall somewhere here. All right, 20 degree here, 30 degree. So this is how we calculate the pitch from these these circles. We have to calculate these lines.
Sir, the pink mark which we are considering, sir, is the one at the north or the one
Hey,
at the
see, so we always take the piece. If you are measuring, if you are taking your data in a uh, so what is it, right hand thumb rule, if you are measuring data from right hand thumb rule, so you will always have the data from the thumb end, like, so whichever the strike you are uh, taking, right? So the strike end that will be coinciding with your thumb. So that strike, from that strike you have to calculate the pitch, right? But if you are not measuring data using that rule, so whatever end, from whatever strike end you are measuring the data, you have to write that from this strike end, right? From here you will huh?
Sir, my doubt is that there are two pink dots. So
Yeah.
which one are asked for?
Oh, so certainly this one. So this is not this is red.
Green is not visible, sir.
Okay, so this is your my screen is not visible. Okay,
No, sir.
obviously this one, can you see it?
Yes, sir.
So this is not this is just to mark the north.
I answered for that dot. That's why my answer was
Oh,
wrong.
no, this is for this one. This is within the stereo net. Yeah.
Okay, sir.
Okay, so I don't think that we have anything more to discuss for today. If you have anything else, do you have anything else, or should we stop the session?
Sir, I have a doubt.
Okay.
Sir, in stress lecture part 2, in the isotropic and deviatoric section, there was a problem.
Okay, can you tell the problem?
Huh?
Can you let us know what's your problem? Matlab, what's your doubt?
Please open the PDF in which
Which
uh,
page?
uh, isotropic and deviatoric section.
Stress 2. Yeah. Hmm.
The screen is not visible, so I'm not able to verify.
Yeah, this one, right?
Uh, mm,
Isotropic and deviatoric, you said.
the previous one.
This one?
Yes, this one.
Okay.
So in the last equation, sir, I have a doubt that if we are subtracting something from a matrix, how it is again equal to itself.
Okay. Uh, so actually, this is not correct. This is not correctly written here. So what is So what they have tried to do here is that so one part of this is missing here, right? So it will be plus sigma 0 0 0 0 0 like that, sigma 0 sigma 0 sigma 0 like that. So are you getting it what I am saying?
Yes, yes, I'm getting it.
Yeah, so it will,
It is written in on the second page, I guess.
yeah. So it is somewhat like this. So sigma 1 1 minus sigma 0, again 0 0 0 sigma is something like that, right? Yeah. So so whatever maybe this is, so it will be plus sigma 0 like that. Okay, all right. Okay, I think there is a connection problem. Can clarify on bulk modulus and Lame's constant. Okay, yeah. So yeah. So Prince, have you completed the lecture of week 5, all of it? Prince, can you hear me? Okay, he left. Okay. Yeah, so maybe there is some connectivity issue, I don't know. Okay, so you complete all these lectures and we will join again in the next week, all right? So in the meantime, we can use the discussion forum. So through the discussion forum, we can communicate if we are going to have an extra class before the Monday next week, all right? So if you do not have anything else, then I'm going to end the session for today. Okay, yeah. Yeah, so I am ending the session. You have a great week. Complete the courses, complete the lectures, and then we will again meet in the next week. All right? Yeah. Good night, all.